Hello and welcome back to the Master Civil Engineering. In the previous video, we learned that how to find the quantity of earthwork required for a road in banking from the L section, and in this video, we will learn that how to find the quantity of earthwork required for a road in banking as well as in cutting from the L section of a road. I have been given a question which states that estimate the cost of earthwork for a portion of road of 400 meter length from the following data. Formation width of the road is 10 meters, side slopes are 2:1 in banking and 1.5:1 in cutting. Okay, you can see the chainage and the corresponding distance. So for chainage 10, distance is 1000 meter and corresponding RL is 51. And also it is given that the RL of the formation at the first chainage is 52, and thereafter the road is in the downward gradient of 1 in 200. We have to find the RL of formation for the rest of the chainages. Then we will draw the L section, and from the L section we will calculate the quantity of earthwork in banking as well as in cutting. Okay, so to find the RL of formation for rest of the chainage, first you will draw a table having the 8 column. The first one is the gradient, then chainage, then distance in meter, RL of ground, RL of formation, height of bank and depth of cutting. Okay, gradient, this is downward, its value is 1 in 200. Okay, for chainage 10, distance is 1000 meter, and for chainage 11, distance is 1040 meter, and so on for the rest of the chainage. Also it is given that the RL of the ground at the first chainage, this is given as 52. Okay, and thereafter the road is in the downward gradient 1 in 200. Okay, total distance from chainage 10 to chainage 20, this is 1400 minus 1000. Okay, so it will be 400. Total distance is 400, and gradient, this is 1 in 200. So total fall from the chainage 10 to chainage 20, this will be 400 divided by 200, which is 2 meter. Okay, and the corresponding distance interval from chainage 10 to chainage 20, these will be 10. That is from chainage 10 to 11, chainage 11 to 12, and so on till chainage 20. These will be 10 distance interval. So difference of height between the corresponding RLs, this will be 2 divided by 10, which is 0.2 meter. Okay, it means if the RL of formation at the first chainage is 10, RL of formation at chainage 11 will be 52 minus 0.2, which is 51.8. okay, and RL at chainage 12, this will be 51.8 minus 0.2, which is 51.6. okay, so simply select this either 51.8 or 51.6 and drag it till the last row, and Excel will automatically calculate the RL of formation for the rest of the chainage. You can see the difference between the RL of formation at chainage 10 and chainage 20 is 2 meter. Okay, after finding the RL of formation, now we will find the height of bank or depth of cutting. You can see from chainage 10 to chainage 15, RL of this formation, this is greater than RL of ground. Okay, so for this portion, that is from chainage 10 to chainage 15, we have to fill the existing ground to raise the ground up to the formation level. So here we will have the height of the bank. Okay, and thereafter from chainage 15 to 20, RL of ground is greater than RL of formation. It means we have to cut the existing ground to the formation level, and there we will have the depth of cutting. So our height of bank, okay, from chainage 10 to chainage 15, this will be equal to reduced level of formation minus reduced level of ground. Okay, which is 1 meter for the first chainage. Select this 1 meter and drag it till the chainage 15, and you will get the height of the bank from chainage 10 to chainage 15. Okay, and thereafter we will have a depth of cutting. Depth of cutting, this will be equal to RL of ground minus RL of formation, okay, which is the depth of cutting, which for chainage 16 is 0.4. okay, and select the 0.4, drag it till the last row, and you will get the depth of cutting from chainage 16 to chainage 20. Okay, so from chainage 10 to 15, you have to fill the ground, and from chainage 16 to 20, you have to cut the ground. Okay, after finding the height of bank and depth of cutting, we will now draw the L section of the road. To draw the L section, you will select these 3 columns, that is distance in meter, RL of ground and RL of formation. and then you will click on the insert button, go to the charts and select this, that is the scatter with straight lines. Okay, then first increase the size of the chart. Okay, we will make some modifications to the chart. Okay, so first we will make a modification to the horizontal axis. Okay, for the chart title, write simply, for the chart title you will write reduced levels of existing ground and proposed road. Okay, okay, then add the axis titles. For horizontal axis you will write distance in meter, and for the vertical axis you can write the reduced levels. Okay, our first chain is starts at 1000 meters, so select the horizontal axis, go to the axis options, let the minimum value be 1000 and maximum be 1400. Okay, which is our last chainage, and let the units of measure, since our distance between the corresponding chainage is 40, so let it be measure be 40. Okay, so this is our L section. Okay, you can see from chainage 1000 to this chainage 1200 we have to fill the ground, and thereafter from this chainage 1240 we have to cut the ground. Okay, orange one is the RL of formation and blue one is the RL of ground. From you can see that from station 1200 and station 1214 the road passes from this banking to cutting. Okay, so we have to find the distance where our road passes from banking to cutting. This is between station 1200 and station 1240. At station 1200 the distance between this RL of formation and RL of ground, this is 0.3 meter, and at station 1240 the height difference between RL of formation and RL of ground, this is 0.4 meter. Okay, so you will simply make a triangle like this. At 1200 we have a height difference between RL of ground and RL of formation 0.3, and at station 1214 we have a difference between these two RLs, RL of ground and RL of formation 0.4. so we will get two triangles. Okay, and total distance between this is 40 meter. So the distance where the road changes from banking to cutting, let it be x from station 1200. Okay, so this distance will be 40 minus x because total is 40 meter. From the theory of similar triangles you can write this x divided by 0.3, this is equal to 40 minus x divided by 0.4, and if you solve the value of x from this it will be 17 meters. Okay, so you can say that our ground road changes from banking to cutting at a distance of 17 meter from this station 1200. Okay, or from at a distance of 1200 17 meters road will pass from banking to cutting. Okay, so after finding this distance, okay, this distance where our road changes from banking to cutting, we can now calculate the quantity of earthwork required for banking as well as cutting. Okay, so let's find the quantity required for banking as well as cutting of earthwork. After finding the height of bank and depth of cutting, you will draw a table in Excel having the 10 columns. Okay, the first one is the chainage, then distance in meter, height of bank or depth of cutting, mean height, central area, side area, total area, length between stations, and earthwork quantity in banking and in cutting. Okay, formation width of a road is 10 meters, slope is 2 for banking and 1.5 in cutting. Okay, you can see the cross section for the banking, okay, and cross section for the cutting. Okay, so side slope, this is 1:2 in banking, that is 1 vertical is to 2 horizontal in banking, and for cutting it is 1 vertical is to 1.5 horizontal in cutting. Okay, and formation width, this is 10 meter. Okay, this top width is 10 meter. We already know this depth of banking and this depth of cutting for different chainages, which I have already written. We know this chainage, distance in meter, and this height of bank or depth of cutting, we have already calculated it earlier. Now the mean height, okay, that is from chainage 10 to chainage 11. This will be the average of height, that is average of 1 and 0.9. So select 1, then select 0.9, close the bracket, divide it by 2 and press enter, and you will get the mean height. Okay, this is the mean height for chainage 10 and 11. Okay, to find the mean height for the rest of the chainage, simply select this and drag it till the last row, and you will get the mean height of the for the different chainages. Okay, then the central area, look, for this cross section we will divide it in two parts. The first one will be the rectangle, and then the rest of the area will be the area of these two triangles. Okay, so this area, central area, this is rectangle, which is b into d, and the area of the two triangles, it will be sd square. Okay, two triangles, if you combine this, area of one triangle will be half of sd square, and for the two triangles it will be sd square. Total area will be the sum of central area plus side area. Okay, so central area, this is simply formation width multiplied by the mean height. Okay, formation width is 10, so for chainage 11, central area from chainage 10 to chainage 11 will be 10 multiplied by the mean height of chainage 10 and chainage 11. So multiply 10 with the mean height at chainage 11, which is 0.95, and press enter, so you will get the central area, which is 9.5. Then select this 9.5 and drag it till the last row, and Excel will automatically calculate the central area for the rest of the chainages. Also, you can see that I have written this chainage of from where the road changes from banking to cutting, and its distance in meters 1217. We already calculated it earlier. Okay, it was 17 meter from this 1200. Okay, so distance will be 1217 where our road changes from banking to cutting. Okay, this distance, okay, that is this portion from this to this length, this is 17 meter. Okay, here that is at a distance of 1270. Road changes from banking to cutting, thereafter we have to cut this portion. Okay, so after finding the central area, you can now find the side area. Side area, this is equal to sd square, but the value of s till for banking this is 2, and thereafter for cutting it is 1.5. so for banking, s, take the value of s2, multiply it with the square of the mean height. Okay, so square of the mean height, that is 0.95, take its square. Okay, and press enter, and this is the side area for from chainage 10 to 11. To find it till the chainage 1217, simply drag it, and you will get the side area till the chainage 1217 where our road changes from banking to cutting. Thereafter our side area, we have to calculate the side area of the cutting. Okay, and for this the slope is 1.5, so write equal, then write 1.5, multiply it with the mean height, which is 0.2 square, and then press enter, and you will get the side area at this chainage 16, which is 0.06. Okay, then select the 0.06 and drag it till the last row, because thereafter we have the road in cutting. Okay, and you will get the side area from chain age 16 to chain age 20. Okay, so after finding the central area as well as the side area, you can find the total area. So total area, this is central area, that is 9.5 plus 1.81, which is the side area. Press enter and you will get the total area between the chain age 10 and 11. Okay, then select this 11.31 and drag it till the last row and you will get the total area for the rest of the chain ages. Okay, length between the station, this is the difference between the corresponding chain ages. So it is for from chain age 10 to 11, length is 1040 minus 1000. Okay, press enter, this is 40 meter. Similarly, to calculate the distance for rest of the chain age, select this 40 and drag it till the last row and you will get the chain age length between the stations. Okay, now the quantity of earthwork in banking and in cutting. Okay, so we have the earthwork quantity in banking from chain age 10 to this chain age that is from at a distance of 1000 to 1217. Okay, where our road changes from banking to cutting. Okay, so multiply simply this total area with the length between station. Total area for chain age 11, this is 11.31, multiply it with length between station, which is 40, and you will get the quantity of earthwork in banking from chain age 10 to chain age 11, which is 452.2. and select this 452.2, then drag it till 1217 meter distance and you will get the earthwork in banking for the different chain ages. Thereafter we have the road in cutting. Okay, again you have to multiply total area in cutting, which is 2.06, with the length between the station, which at chain age 16 is 23. Press enter and you will get the quantity of earthwork in cutting at chain age 16. Okay, then select this 47.38 and drag it and you will get the quantity of earthwork in cutting from chain age 16 to chain age 20. Okay, then take the sum of these readings. So quantity of earthwork in banking, its sum, write equal sign, then write SUM, then bracket, then select these values, that is from 452.2 till 26.3, then close the bracket and press enter and you will get the quantity of earthwork in banking. Similarly, to find the quantity of earthwork in cutting, write equal sign, then write SUM, then bracket, then select from 47.38 till 309.4, close the bracket and press enter and you will get the quantity of earthwork in cutting. Okay, so now you know the quantity of earthwork in banking as well as in cutting. You can calculate the cost of earthwork required. Okay, so you can see in Excel we can easily calculate the values. Okay, we just have to calculate for the one value and then Excel will automatically calculate the value for the rest of the chain ages or stations. Okay, so you will fastly calculate the values. Okay, now earthwork in banking, its quantity, total quantities, write equal sign and then select this, that is 1821.3 cubic meters, and let us assume the rate is $5 per cubic meter. So cost for earthwork in banking, this will be 1821.3 multiplied this $5, which is equal to $9,106.325. And quantity of earthwork in cutting, this is 1385.08 cubic meter, multiply it with the rate, which is $3. Okay, and you will get the cost of earthwork in cutting, okay, which is $4155.24. Total cost, this will be the sum of these two. Okay, so take the sum of these two, that is 9106.325 plus 4155.24. Okay, select these two values, close the bracket, press enter. This is the total cost for our earthwork in banking as well as earthwork in cutting. Okay, so this way you can use the Excel to draw the L section, and from the L section calculate the quantity of earthwork in banking as well as in cutting for any road. Okay, if you know the reduced level of the existing ground and reduced level of the formation level. Okay, I hope this solution video was clear and effective and it will help you in any way. Okay, if you find this video helpful, please share this video, subscribe to my channel, and also like this video. And also, if you have some doubts, you can write them in the comment box. I will be happy to answer this. Thanks for watching Master Civil Engineering, and stay tuned.